Recent observations of 3I Atlas have revealed something truly unexpected, something no astronomer has ever witnessed before. In the 4 months since this interstellar comet was discovered, it has transformed from a distant curiosity into one of the most puzzling objects humanity has ever observed. The central question has shifted from where did it come from, to what is this thing really? Let's explore for strange discoveries about 3I Atlas that have only deepened its mystery. Each discovery challenges our understanding of comets, interstellar space, and potentially the laws of the universe. The first indication that 3I Atlas is extraordinary came from its immense scale. Early Hubble measurements suggested a nucleus up to 5.6 kilometers wide, comparable to the size of Manhattan. But the true shock wasn't its size but its mass. Using precise data from the James Webb Space Telescope, scientists calculated that the comet must have a minimum mass of 33 billion tons, making it at least 1,000 times more massive than the first two interstellar visitors, Oumuamua and Borisov combined, a genuine interstellar heavyweight. Scientists determined this mass not through direct measurement, but by observing what the comet wasn't doing. As comets approach the sun, their ices vaporize and erupt as jets, a process called outgassing. These jets function like tiny thrusters, pushing the comet slightly off course. Astronomers refer to this as non-gravitational acceleration, observed in almost every active comet. Despite 3I Atlas outgassing heavily with jets everywhere and a wildly active coma, its orbit remains perfectly governed by gravity without a single detectable wobble. The only explanation for such powerful jets having no measurable effect on its path is if the object possessed enormous inertia. The absence of this recoil effect led scientists to conclude its mass had to be at least 33 billion tons. This is where the paradox began. According to our models of planetary system formation, small objects are far more likely to be ejected into interstellar space than large ones. That's why the first two interstellar visitors were tiny. They fit the theory, but discovering a supermassive comet like 3I Atlas perfectly aligned within just 5 of the solar system's orbital plane is statistically unusual. To some scientists, this combination of huge mass and an unusually precise entry path suggested that 3I Atlas's arrival might not be coincidental. If its mass was the first surprise, its appearance was the second. By comet standards, 3I Atlas was misbehaving. Comets are known for their tails, which always point away from the sun, pushed back by solar wind and radiation pressure. That's fundamental comet physics. But when astronomers captured early high-resolution images using the Hubble Space Telescope and the 2-meter twin telescope, they were astonished to see something different, a bright, well-defined jet of material pointing directly toward the sun. Initially, scientists wondered if this could be an anti-tail, a known optical illusion caused by Earth's edge-on view of a comet's dust trail. But this wasn't an illusion. Further analysis confirmed this was a real, physical tendril, a plume of gas and dust extending into the sun's glare, defying every textbook rule of cometary behavior. In early October, the mystery deepened further. New images from the Nordic Optical Telescope showed that the bizarre sunward jet had vanished. In its place, 3I Atlas now displayed a conventional tail, streaming away from the sun like any normal comet. What caused this transformation? The leading explanation suggests that 3I Atlas is far more complex than any comet previously observed. The early sunward plume likely consisted of very large, heavy dust particles, each around 100 micrometers wide. These grains were too massive to be pushed by sunlight when the comet was still distant from the sun, so they simply fanned outward in the direction of travel, creating a forward-facing plume. As the comet plunged deeper into the inner solar system, sunlight intensified, eventually gaining enough pressure to push even these sluggish particles backward, reshaping the plume into a traditional tail. This wasn't merely a visual transformation, but a clue pointing to a layered, chemically diverse object made of materials that respond to solar energy on different time scales. 3I Atlas wasn't a simple dirty snowball, but something far more intricate. The most significant indication that 3I Atlas possessed an alien chemistry came from the comet's water controversy. In July and August, NASA's Swift Observatory made a stunning announcement. Using ultraviolet observations, a team detected hydroxyl, a telltale byproduct of water molecules breaking apart in sunlight. Their analysis suggested that 3I Atlas was releasing water at a rate of 40 kilograms per second, equivalent to a fire hose blasting in deep space. This claim was astonishing because at that time, the comet was still 3 times farther from the Sun than Earth, a region so cold that surface water ice should remain frozen solid. The finding suggested something rare. Sunlight might have been heating tiny ice grains, already ejected from the comet's surface, causing them to release water vapor far from the Sun. This painted a picture of a uniquely water-rich interstellar traveler. But just as this narrative took shape, it collapsed. In the same month, NASA's Spheric Space Observatory examined the comet using infrared light and found no significant water cloud at all. In fact, it placed an upper limit on water loss at just 4.5 kilograms per second, nearly 10 times lower than what Swift had claimed. Instead, Spherics detected something else. It observed an enormous, glowing coma of carbon dioxide, with the comet sublimating the compound at a rapid rate of 70 kilograms per second. Later, the James Webb Space Telescope confirmed this. 3I Atlas had a carbon dioxide to water ratio of 8:1, among the highest ever recorded in any comet, solar or interstellar. The two datasets contradicted each other. Was one of the telescopes simply wrong? To space telescopes, two completely different stories. It was a reminder that even in science, the truth depends on where you're looking and how closely. Most people only see a narrow slice of reality shaped by the sources they follow and their location. And when it comes to science news, it becomes even more complicated. Headlines are often exaggerated or oversimplified to attract attention. As debate continued in October, a more nuanced explanation emerged. Swift had detected hydroxyl, an indirect, but a highly sensitive signature of water vapor breaking apart. Spherics and Webb, on the other hand, had measured the actual infrared glow of carbon dioxide and water molecules, a more direct method. The leading theory reconciling these observations suggests that both telescopes were correct. They were simply observing different moments in the comet's evolving activity. The fire hose of water Swift detected may have been a brief outburst, a sudden release of water from ejected ice grains. Meanwhile, the true driving force behind the comet's activity all along was carbon dioxide. So, 3I Atlas wasn't simply wet or dry. It was a carbon dioxide-dominated alien body with a strange, powerful way of releasing water where no ordinary comet should. Another layer of complexity, another rule rewritten. The most provocative clue about 3I Atlas didn't come from its size, its tail, or its strange behavior. It came from its chemistry. Using the Keck telescope in Hawaii, astronomers analyzed the light coming from the comet's coma and found something unprecedented. A strong spectral signature of atomic nickel, with virtually no iron, in every known natural object in our solar system. Comets, asteroids, moons, planets, nickel and iron always appear together. They are forged side by side in the hearts of dying stars, and they condense together into solid minerals. The ratio may vary, but the two metals are inseparable. Until now, a pure nickel signal without iron was, from an astronomical perspective, deeply unnatural. This observation prompted Harvard physicist Avi Loeb to propose his boldest hypothesis yet. He noted that this exact kind of iron-free nickel signature is a known byproduct of industrial processing on Earth. Specifically, the carbonyl refining process used to purify nickel produces a compound called nickel tetracarbony, a highly volatile molecule that breaks down in sunlight, releasing pure nickel atoms. For Loeb, this wasn't just strange chemistry, it was potentially a technological fingerprint, a hint that 3I Atlas might not be entirely natural. Other scientists rushed to find natural explanations. Perhaps a similar carbonyl reaction could occur naturally under specific conditions near the comet's surface. Or maybe the nickel came from a previously unknown metal-bearing molecule, like a polycyclic aromatic hydrocarbon that degrades near the Sun, releasing concentrated nickel close to the nucleus. But the mystery deepened further. The ratio of nickel to cyanide, another compound commonly seen in comets, was found to be orders of magnitude higher than anything observed before. This wasn't just unusual, it was off the charts. Whatever the cause, one thing was clear. The chemical signature of 3I Atlas doesn't match anything we've seen in our solar system. It is a message from an alien environment, formed in a star system with a very different recipe for building worlds. And whether natural or not, it challenges our assumptions about what's possible in astrochemistry. This isn't just another comet, it's a comet unlike any other. With the upcoming full-sky survey by the Vera C. Rubin Observatory, we're on the verge of discovering many more interstellar objects passing through our solar system, perhaps dozens, maybe hundreds, and with a larger catalog we'll begin to uncover patterns, origins, and possibly even entirely new classes of cosmic visitors. Each new interstellar object will carry clues, not just about its journey, but about how other worlds form across the galaxy. 3i Atlas may be the strangest we've seen so far, but it certainly won't be the last. As our detection capabilities improve, we may find that the universe is filled with far more diversity than we ever imagined, challenging our understanding of cosmic chemistry and planetary formation. The story of 3i Atlas reminds us that even in an age of advanced telescopes and sophisticated models, the universe still has the capacity to surprise us. Each new discovery doesn't just answer questions, it often raises even more profound ones about our place in the cosmos, and what might exist beyond our solar neighborhood.